She is a travel junkie, proprietor at Poundstone Wines right here in California, a women in tech advocate, adventure seeker, and a mom. Please join us in welcoming VP of Engineering at Google, Melanie Meckfessel. And together with her, he is a self-professed huge nerd, Van Halen fan, and dog lover. Please welcome VP Product Management for Google Cloud Platform, Sam Ramji.
Good morning.
Good morning. I think we need a clicker.
I think we need a clicker, and I think we need coffee. How are you doing on coffee? Recharged? It's great to be here. So many amazing practitioners here. I just saw Boccia Galupe, which is how I knew John Willis for years before I finally got to meet him in person. The range of real experience and insight here is going to be awesome for everybody attending the next couple of days. So we're just happy to be around.
Yes, I am happy to be back. My name is Melanie Meckfessel. I lead the engineering team focused on DevOps at Google, which covers Googler, developer and operators within our Alphabet family, developers using mobile development, and developers using our cloud platform.
Yeah, and I lead product management for Melody's organization, and she's being very humble as usual. Almost 1,000 Googlers serving a niche market of about 45,000 Googlers who are building software and maintaining our services. But what we're going to try to talk with you about today is a few things on how to get management on board, because that's something that we're doing in bringing products to the market, explaining why these things matter and what the DevOps revolution looks like in a way that you can explain it to your CIO. We'll talk about how we actually do things at Google, show you some new technologies that we just brought out, and then maybe close with how we think about management. So hopefully we offer these things to you. Many of them you already know. A few might be surprising. But one thing that we always find when you're trying to lead change, as so many of you are, no person's a prophet in their own country. So if the words that we're offering and the slides that we're using help you tell your own story, then we'll be really happy. All right.
Oh.
Next slide, please.
Yeah, next slide.
The journey begins.
We're not even at the demo. Okay, any humans in the crowd? Yeah, there we go.
So being the PM, I have to look at the analysis. So we're about 37% humans. Are there any humans in the crowd? Any non-humans yet?
Yeah.
No, okay.
Well, I like
somebody's ascended. We got a non-human. Very good.
To me, whenever I think about DevOps, I have to back up a bit and talk about why are we all here? Why are we contributing to this space? Why are we passionate about it? And I think it's important to ground in everything that we're doing over the next couple of days at JFrog in the humans, which is us as practitioners, developers, and operators of software. And it's the community that we're collaborating with, partners, members of our teams. It's a very difficult time right now with the transition to cloud technologies to be a developer and operator. And I like to remind all of us that we can bring insight and empathy to the challenges that exist in DevOps. Because it is challenging, and I think we're all here to help and contribute to that. So remember, happy and productive humans. That's why we're doing this work.
All right, so a lot of people here know a lot of languages. I saw the survey on Go, but I couldn't see who raised their hand. Who here uses Go? Bunch? Okay, and how many people use and know how to communicate in Perl? Okay, and how many know pointy-haired boss? Awesome. So I have an opportunity to help like 90% of the audience speak pointy-haired boss. You ready? Okay, here we go. Why do we do DevOps in one slide? It's about bringing ideas to market faster. How do we go from concept to money? Right, we can call it the market, but really we mean money. Pretty much the top-down view is this is all working, and you make a set of promises, and the company gives you money, and you bring things out. And then you say we've got this new way of doing things that solves the impasse between business people and requirements and getting those ideas in code. Well, what's wrong? Well, the business people say, I want the thing. It takes you several months to build the thing. By the time you come back, they say, I don't want that thing. I want a different thing. So we created Agile. When we talk about DevOps, often we hear, oh, doesn't Agile solve that? And then we have to say, in fact, it doesn't, because there's another barrier between development and operations. As you'll see later, if it works on my machine and marketing is happy with it, that doesn't actually make you money because it hasn't made it to production. So very simply, DevOps solves this. Between Agile and DevOps, we have a complete package, which hopefully will take us to heaven. All right, so take a moment and think about the cloud in 2010, kind of your compute environment. This is 8 years ago. Think about your job title, what company you were at. That cloud was actually very developer-centric, and it was just infrastructure, right? So developers were building their own developer tools, bringing their own app platforms, and building on top of infrastructure as a service, which was abstracting the physical resources. It only took about 5 years before everybody expected, oh, platform as a service is baked into the cloud platform. DevOps tools become the new bespoke piece that you're bringing to bear, and everybody's talking about cloud is built for developers and operators, right? How do we do both of these things? So that's a helpful frame we've found for explaining how it's changed. Then there's a shift to where it's going, right? So when we look at where we're going in 2020, and I imagine, we'll see how this test goes. How many of you rolled your eyes when you saw DevOps AI up there? Excellent.
No judgment. No judgment.
So we are going to show you some stuff that actually is AI under the hood, which is a good, solid automation to make better use of happy, productive humans. But if you start to look at the trends, if you look at startups, if you look at what tools are being brought to the market, we're starting to see these things get built into the cloud platform, right? And developers and operators are just obviously the software team you work with. Here's really good news. This is a chart, and of course, if you want to speak proper pointy-haired boss, you need to have an authoritative chart like this, so please use this one. Even if it didn't work, CIOs need to talk with their CEOs about DevOps. Why? So this chart shows the consensus view of IDC, Gartner, Evans, Forrester, right, all of the big research companies that really sell their ideas and their analysis to senior management. And it really doesn't matter how far up the management chain you get. Eventually, you'll find somebody who's reading these. The consensus view over the last few years is everybody's adopting DevOps, right? It is the way of the future. Even more so, even if they don't read these, they will read the headlines, right? Always know what your manager's manager is reading. That's the secret of speaking pointy-haired boss. Boston Consulting Group, IDC, Gartner, Bain & Company, Forrester, McKinsey & Company, they're all telling all of these people, if you want faster IT, DevOps is the solution. So just imagine the conversation between the CEO and the CIO. So I was reading this thing about DevOps. Are you doing DevOps? No, it's not quite ready yet. We've got this other thing. It's way better. That is not going to happen, right? The CIO's job is already hard enough. So you can rest on a level of confidence showing this to your management, because often the connection between line management, next level up, and finally getting to the C-levels gets lost in translation. So these slides can actually probably carry your message all the way through. And underlying it, the system is pretty clear, right? We're in a transition to software teams, right? You don't win a basketball championship with one point guard, right? You have a software team. I'm very proud of the Oakland Warriors. I'm from Oakland. They have a very balanced attack. They've got a team that everybody works together, right? Jobs aren't entirely interchangeable. They try not to have stars. It's a team. So those teams of developers and operators ship much faster, right? Melody, you see this every day.
I think, 10x improvements, maybe more, when the teams are working together. And we're actually going to model this for you through some of the tools later on in this talk.
Yeah, and the speed of development and the speed of deployment is what wins these teams the political capital to say, we're going to pick our own tools, which in turn changes the game for operators. What we're seeing a lot of operations teams, and certainly something that we focus on ourselves at Google, is that you've got embedded teams that are building and managing the software, and an operations platform's got to provide observability, right? The problem changes from, can I do anything with it at all, to, oh my God, we have so much data, we have to give you the moral equivalent of data science tools, right?
I would just share, the first time I had to carry a pager for the software that I wrote was one of the most educational experiences of my career. And I feel very lucky that it happened early on, that I was waking up in the middle of the night with a page or an alert and going back to look at a piece of code that I'd written and think, oh my gosh, I just did this to myself, and never wanting to do that again. So it is this combination of the humans, developers and operators, the tools, and then the practices and the culture that we put around that.
You feel lucky now.
I feel lucky now.
But when the pager went off back in 2000,
No.
not as much fun.
No.
Yeah, I ran engineering at Ophoto. If anybody remembers Ophoto, it was a lot like Instagram 10 years earlier, worth about $950 million less. But I had just switched from the world of package software where you just ship it to run it. Oh my God, right? So developers who carry pagers write better code. So finally, I want to focus on where the common sense is going in the new rules for leadership. If you pick up a Harvard Business Review, right, again, how do you speak pointy-haired boss? You read what they're reading. So what they're reading, they're all pointing back to these themes. Openness, abundance, and empowerment. Right? Every board is now asking their CEO, what's your technology strategy? Right? They're not just asking what your security is, but what's your technology strategy? Are you getting faster? So in turn, they're saying, well, what's the most impactful strategy? Openness, are you using open source? Are you sharing ideas? Are you using open APIs? Abundance is really important, and I want to offer you this. Humans don't deal real well with changes in economic abundance versus scarcity. So what do I mean? We evolved slowly in a world of slowly changing technology. There was a study done by a couple of economists in England a few years ago on the change in the cost of light from the Dark Ages to now. From 1300 to 1800, 500 years, right? About, what, 20 generations? The cost of light improved by a factor of 3. It was measured in pounds sterling per lumen. You can Google it if you like, or I can share this with you later. From 1800 to 2000, only 200 years, it improved by a factor of 3,300. Right? We lit the world. So, but you still had 200 years to deal with that. Now, from 1992 to 2012, the cost of a compute cycle improved by a factor of 3,700. It's not 3,700%, it's 3,700 times. Hold on to your hat. Storage in that same time improved by a factor of 18,900. So for those of us who grew up when things were still on the early end of the curve and scarce, we have to help everybody, right? And management tends to be a little older. We have to teach everybody, hey, there's a new abundance. And if you're protecting your hardware resources and not spending money on that, you're throwing away the time that your people have, right? That kind of abundance thinking leads to empowerment. And that's the critical insight that's showing up everywhere. We're even seeing, if you pick up the latest Harvard Business Review, you'll see that major companies with tens of thousands of employees are recomposing their businesses into like 500 or 1,000 agile teams. It's about letting teams move faster, and that's part of what we do, right? Empowerment through giving people an API instead of making them send a ticket to get more servers. So empowerment is the key of how we build software and what Melody has built in this 1,000-person team.
So again, the humans. The humans are why we do this. And it's an exciting time to be developing software and operating services on cloud platforms. But it's also challenging in many ways because there's a lot of choice. And there's glue that we need to build to bring the pieces together. Oftentimes they're not well-lit paths for the things that we want to build. So to come back to how does this relate to people, we're seeing, and I'm sure you all have experienced, different sizes of teams, teams playing different roles, teams being distributed over different geographies, language preferences. I wore my Gopher today, my Gopher t-shirt, right? Those changes are not going to go away. And we as a community need to be able to respond and evolve in a way that continues to help improve productivity of the people. We see challenges in terms of how do you build practices that help humans collaborate instead of throwing something over the wall, as Sam mentioned? How do we help embed the culture and the practices in the tools and the everyday experiences that developers and operators are having? So at Google, this is a very oversimplified model, but we support diversity of languages. And here's a developer who, going to write a patch for a component that has many, many dependencies. And there are tools in the background to help her identify what those dependencies are. And then when she's ready, before she submits the patch, there's a lot of testing that we do in the background, pre-submit tests so that she knows what she's going to break. And the reason I wanted to start with this is that when you build automation around continuous integration and then in continuous deployment, the developers feel like these systems, the CI, has their backs, right? And I think that's an important part of this. Developers will take more risks and potentially move faster when they know that there's something there to help them identify an issue before it gets to production. And that type of, not just the tooling, but the mindset continues to sort of build trust between developers and operators because they're putting the time in to test to make sure that something high quality is going out to production. And then we send it for review. We do code reviews. We invest a significant amount of time in code reviews to help improve the quality of the code that we're delivering.
And so behind each of these is a fairly specific set of tools, right? We've got things that will enable you to do security analysis, know what the dependencies are, things like tricorder who say, I can find the 27,000 different places my library is used, so I know just how big the impact might be. I can test it against the entire Google code base because we live at head and use a mono repo. And then code review brings other humans back into the loop to make sure that no one of us failed. So there's a whole constellation of tools that are chained together and enabling the experience to be a lot faster and more productive.
Thanks, Sam. So developers want an amazing stack, and the thing that we hear time and time again, and speaking with software teams working on the cloud, is this idea of integration. And integration doesn't mean a monolith or one tool to do it all for me, but it does mean that I have the best tool for the task that I'm trying to execute. Whether I'm debugging a production issue or I'm writing code and I want insights and recommendations for improvements. We invest heavily in libraries and reuse around libraries, so we have tools to help developers and operators discover code that they can reuse. And all of this contributes to the time to get that amazing feature that the developer wants out to the user community. All of this is this continuous cycle of improvement to not only improve the code and improve how the service is operating, but to bring down the toil that we all feel, right? To find opportunities to automate when we encounter something that is consuming a large amount of time. And I am very inspired by what I'm seeing in open source development and contributions and collaboration in this space so that we can all have a voice in that.
And as a developer, this is exactly what I want, right? And this makes me feel awesome. But as an operator, I also want a stable and reliable production stack. I want to ensure that there's consistency among environments, right? As I'm looking at resolving issues in production that are impacting our users. And I need tools, I need insights into observability so that I can understand what's happening. And I would like to not be paged in the middle of the night, so don't break it, Sam, developer Sam. We're going to get there in a second. So this is just a little bit about our development process. I just want to highlight a couple of things that I think have to do with velocity. We've kind of tuned our build and test cycle so that developers are not waiting on build times. It's like this classic, okay, I'm going to execute the build and I'm going to go have a cup of coffee or go play a video game. We are trying to get the context switching time down to be very minimal. We found through research that has a huge impact on productivity. I talked about code reviews. We invest significantly in code reviews. For any growing software team, this is just one tool in practice that you can use to help share information and educate each other. And then testing, near and dear to my heart, test. That's how we help me not wake up in the middle of the night with an alert. And that's kind of a nice ratio too. 4 million builds per day is a lot, right? We've had to solve some very difficult computer science problems about scaling, but 500 million test cases per day, so they're provably correct as they go in, right? Don't break the build. A junior developer at Google can submit a patch to search. They can see all the code. Don't break search. That'd be an issue. Right, so being able to have the test suite get your back, right, you're going to be in good shape. And that all depends on this very particular style of tooling and a methodology for what are the artifacts, which Melody is going to talk about.
So I think about this in 3 principles around our engineering culture. Readability, because we care about the quality of the source code. Transparency, Sam just gave a great example of engineers having access to the code to be able to not only find something that they can reuse, but also help fix each other's bugs and have that collaboration happen. And then automation, we just saw from the stats, the build and test stack, having the back of the developers and operators has been a critical part to finding that velocity in our DevOps cycle. So just a couple of other things I wanted to highlight. We've been doing a lot of work to make suggestions in some of our tools. So it's kind of, we call it the robot code reviews. There's humans and automation to bring improvements and insights and recommendations for fixes. On the automation front, we're trying to, just going to highlight, we're trying to do a better job with scheduling, because we know at scale you need to be smart about how you pick the test cases that matter the most. And then on the transparency side, I very much appreciate, in order to have the openness that Sam mentioned, where we're defining high quality APIs and having the reliability behind those, we need to evolve and we need to change. And so in order to support that change, we have tools that do large scale refactoring where, in a matter of minutes, we've identified all the call sites, 10,000 plus. We've come up with a list of change lists. We've submitted those for review, and then we make that change happen.
And these are tools that hopefully will be useful to you. So one of the conversations that we're bringing and we'd like to engage with you in later is, what if this catches your attention and you think like, boy, I'd like to have that? Because we're sitting on this vast 19-year history of all these tools that have made Google build at scale and at reliability, right? High velocity, about 10,000 pushes to production per day. High reliability, most of our services are 4 or 5 nines uptime. We want to bring those tools out and offer them available to everyone. So your feedback would be really helpful here.
Great. So here we have our developer. I just want to ship it. Just move it out there.
As often as possible.
Our operator, please don't break it. I don't want to be paged in the middle of the night. And then DevOps, right? DevOps, the practices as practitioners, why can't we have both? So we're going to get into a demo in a second, but I want to come back to what I think is an important part of this is modeling the culture and the environment and bringing that into the experience that the humans have. So you can have a lot of automation around build and test and CI. You can have great monitoring and the logging. But if you still have a culture where it's thrown over the wall and the humans don't trust each other, you're not going to get that magic. You're not going to get the speed of debugging production issues.
I can't just use git blame.
We're gonna play this out. We're gonna play this out in a demo in a second. But I think that's an important part that we bring into our experiences as practitioners every day. How are we modeling trust? How are we sharing our understanding of what's happening so that we can get to a solution faster and reduce toil for all of us? So these are the 4 points we want to demonstrate today. We rely heavily on data to guide us in decision making and our understanding of what's happening in the code.
And because we're a distributed systems company, right, we all understand the core concept of shared fate, right? When the cluster goes down, everything on it goes down, right? So we all have to do our part to keep it together. It also helps you design more reliable systems. This idea of collaboration based on shared fate makes it really simple. If it's down, it's all of our fault.
That's
we
right.
better all bring it back together.
That is right. And you know what? When we're in the thick of it and we're in an outage situation, we need to be looking at the same information, right? I can't. It's just not efficient. So we want to make sure we're working off the same data and the same tools. And when we're all done with the outage, we have a weekly Tuesday meeting where we bring that postmortem in and we go through what are the bugs that we need to fix, what are the issues we need to resolve, how are we going to improve our practice, how are we going to improve incident management.
And the spirit here is really Kaizen, right? So much of the same spirit that moves the DevOps community, right? Borrowing from Toyota's production process. You just don't blame the people, blame the process. What is it we're going to fix? We'll make it better every time.
Great.
All right. So I have to tell you, I really like socks. So I went to work for a sock company and built an amazing sock site. And it worked so well that we started amassing a lot of socks. And the business said, we're going to put a flash sale on socks. Right? We've got a 1-hour sale going, 46 minutes remaining. I hear the orders are fantastic. Everything is absolutely 100% fine. But then there's a problem. So my old instinct, of course, is to say, worked on my machine. Have fun.
No. That's not the way
we're not going to model that one?
No, we're not going to do that.
I was just going to use git blame.
No, we're not going to do that. We're going to show how what's another way to do this.
I think you should start.
Okay, so we're going to do two scenarios. One is a latency spike in our SOC application running on the cloud, and the other one is an actual bug that shows up and how we work through that process. So I've got my pager, and I get this page, and oh, what's going on? Why are we having latency issues? And he's backing away. And then I remember, oh, we were in that staff meeting, and the business lead said they were going to do this discount, but they didn't say when. That would have been nice to know. Maybe we can follow up on that afterwards. And then I come in, and I go right to my graphs, and I can see, oh my gosh, QPS is spiking, and look at what's happening with latency. There's clearly a problem here. I need to stop whatever it was I was doing and start to dig in. So I come to Trace, and I can see, whoa, what is going on? And I can look through what's happening. Clearly something is going wrong. Like, I don't need to, waste any more time. And so I'm scrolling through the traces here, and I can see, oh my gosh, I think there's a problem with shipping. That looks very odd. That is way too long to be taking. Something's not right here.
3 seconds on an asynchronous call, probably bad.
Yeah, not good. So I want to do one more thing. I want to come in and I want to look at some comparisons around latency. And I can clearly see like something has gone wrong with one of the releases. Very clearly, we've done something wrong. We need to fix it. So I'm at this point going to talk to my developer on call and say, hey, we've got this issue, and I think it's in shipping. It's clearly happening because this discount's going on. So please take a look.
Got it. So what do I do next? I bring up Stackdriver Profiler, and one of the things I love about Profiler is that it makes me feel warm and fuzzy like I did in the 1990s. When I had all my code on my machine, I could hit F5 run, I could set breakpoints, and I could just see exactly what was happening. This is a profiler that runs in production. So for old dogs like me, this makes us very happy. So taking a quick look at this, I see with the string matching functions going crazy. This is not acceptable latency. This is complicated, and we've got probably 44 minutes left in the sale, and we're losing money on a second-by-second basis. So Melody, one of the functions is taking up way too much CPU second. There is just no way this should be happening. It should all be asynchronous. I can't really fix this, so could you just give us some more cowbell? Because I got a fever.
I love cowbell. So
all right, I'd like to see a few more instances.
I'm gonna work on this immediately, and I'm gonna go set up some instances. So I go into here the GKE UI, and I'm gonna just bump up the number of replicas to solve this problem, and then make sure all is well. And I think in that postmortem, Sam, we need to find some way to know when these discounts are going to happen so that we're just ready to go and we don't waste any time.
Well, fortunately, I speak pointy-haired boss, so I'm going to take care of that one. All right.
OK. So now we're going to resolve an error in production. So I get this screenshot from customer support, and they say, Melody, this doesn't look right. Can you take a look at this? Something seems wrong. And the first thing I do as an operator is I always just go try and reproduce it. So I've got a test instance. I want to make sure that I'm seeing the same thing. And sure enough, I picked some different stocks, but this is a problem.
But of course, you have a test account. There's automation underneath that knows what your ID is, so you don't worry about going and punching that in.
Yes, thank you. So now I'm going into Stackdriver error reporting, which is kind of the first place I go. This should be an error. This should be showing up in my dashboard. And I can see here, there were a couple of errors in the last day, but the dev team is doing a great job. Things are working pretty well, but I'm not seeing this error show up. So I think it's time to get my dev partner on the line. I share all the information that I have. There's some weird shopping cart stuff going on, and Sam's going to take over as the dev on call.
And again, I think I'm so glad that I have tools that work like I was just programming on my machine, but actually are running in production. So first, I just want to figure out, is the code obviously foobarred, right? And so I'm looking through this, and I'm like, OK, as we post, we've got a couple of guard conditions. Make sure the ID is not null, make sure the count's not null, make sure the count isn't less than 1, so that we don't end up paying people who buy negative socks because that's bad. Yeah, it looks fine. I mean, it's logically good, right? So then, I want to start attaching to production. So on the left-hand side, I've got my production website. On the right-hand side, I'm actually getting into inserting a live trace. So I'm going to watch what is memory doing as I'm going through the system. I'm forcing my customer ID in so I don't mess up the customer experience. And I'm looking exactly at this undefined count. What on earth? If we could just compile this stuff, I would have known it in the beginning. So let's take a look at the last diff from the prior pull request. Oh, I see. We've got, at the very top, somebody changed quantity to count. We have a lot of new junior developers coming in, and we're trying to educate them on the style guide. And I think somebody took this a little too seriously, like expressive code, and they thought count just makes more sense than quantity. But that broke this, and that's why it's null. So I'm going to send Melody through the system. The wonderful thing about systems is we get along great, but I don't have to talk to her. I can just say, roll this back.
All right, so Sam's giving me the issue. Great. Looks like we're going to have to do some work, but let's roll this back. We need some time to fix this, and this is clearly an issue. So I'm on it. I'm working on it. So I'm going to come into the container registry, and I'm going to look for the last stable version, and I'm going to pick that, and then I'm basically just going to roll back to that stable version, because when in doubt, roll it back. I find the front end code here. I update to the version to the last stable, which you can see here in the UI. And then we should be good to go. We should resolve this. And we need to follow up with customer support to make sure that we're not getting any more feedback from our user community. But everything looks good to go now.
Well, thanks to your mad Kubernetes skills.
Yeah, exactly. So yeah, just making sure everything gets updated. I can see that version's running, and I think we're good to go.
So hopefully, we reasonably well portrayed the culture inside Google in action. It's probably a culture that you're used to. It's probably something that you see in all the effective DevOps teams that you're part of, right? As Melody said, data guides us, right? We're looking at the data to figure out what's happening, and the data is not just, data by itself is useless. It's the visualization that brings it to life, because we can't spend our entire life going through logs. So how are we understanding the data?
Yeah, and I think we saw examples of that, of us being able to look at the traces, right? Being able to debug, look at what's actually going on in production, and then coming back to the code. We may not have time to fix it, but at least we know what happened and we document it, which is, we're not showing it here today, but we have tickets and documents that we review on a weekly basis to learn from what has happened in these two outage situations. And I think we definitely have room for improvement in multiple areas.
Yep, and we didn't show you all the collaboration tools behind the scenes, but we'll give you kind of a taste of that. Things like incident response management system, establishing roles like the incident commander, right? How do we end up capturing institutional memory? Because you really want to treat this as a knowledge management problem. People are always going to be onboarding your company. People are always going to be offboarding. The ratio will vary depending on how mature the team is and what shape your business is in. But knowledge management for these kinds of critical productions is absolutely essential. You don't want somebody making the same mistake a year later. So this kind of blameless postmortem culture and effective engines underneath it can make us smarter over time.
And I think to me, the concept of continuous improvement in everything that we do is central to DevOps. Central why it's close to my heart. I think it really comes back to how do we help the humans, whether you're playing a developer or an operator role or both, become more productive and happy.
So the three questions that that Melody and I try to guide ourselves by, and we found this across Google, and we found this in a number of places that are changing fast and succeeding rather than changing fast and kind of freaking out. They're very simple questions, but they're provocative, and we ask them in staff every week. We poke each other on IM multiple times a day with some flavor of these. First, are we managing for change? We have to assume that change is normal, right? So are we managing for the pace of change that we're targeting? Second, do we have an effective model? What worked yesterday might not work that well today. Right? Is it a broken model, or is it just a model that needs to be iterated? And then finally, are we open? Are we taking advantage of all the people, the tools, the technology, the projects outside of Google, people around the world, right? What are we doing to engage them? So managing for change.
So that speed,
really a strong suit.
Yeah, so the speed and velocity of you want your build cycles to be happening almost instantaneously so the developers aren't context switching. We want a release process. We want that example where we can very clearly go back and see, okay, something went wrong. We're either going to bump up the number of instances to deal with the spike, or we're actually just going to roll back because that's the most appropriate thing to do. And then, the insight and observability that we have in the monitoring process as an operator to be able to say, okay, we could actually, we could speed up our release cycle, or, I proactively get an alert that our error rates have spiked. So that ability to sort of have the tools and the data at your fingertips to make those improvements. And then the last part of this is the continuous improvement piece that I just mentioned. How are we feeding that back into making the code better? And that's going to lead to what I want as an operator, a stable and reliable production stack.
And then measuring all of this and rendering it in a dashboard so that we can see the cycle time on each of these, right? What's the speed of release? What's the speed of build? And how fast are we iterating the entire thing end to end, right? Do we have an effective model, right? Observability is something that probably most of you are good at or dealing with. If you're still worried about observability, this is going to be a great conference to learn more about what we mean by modern observability. But if you can't see the problem, we can't possibly apply any of the principles we talked about to share the fate, and instead we end up placing blame because we don't know what the hell's going on. Auto update is really nice. It's sort of something we've gotten used to in the world of consumer software, but being able to auto patch, auto redeploy, right? You think about the 3 principles of security: rotate, repave, repair. You want to be able to have an auto update environment, and the edges of the auto update are always going to be where you're going to see failures and frustrated people. And then finally, economies of scale, whether that's cloud, multiple clouds, data centers, even things like how are you doing your power, right? Recently, we released some of our designs as part of the Open Compute project, and we revealed that we get a lot of advantage from using 48-volt power in our data center racks, along with the rack designs themselves. Finally, are we open?
Yeah, so I think there's 2 parts of this. One is, are we being transparent in terms of the humans and the roles that they're playing and the decision-making process around the practices that we have? So certain teams within your organization may have different release management policies. You want a human to be able to look at it, or you want to automate that you're just doing nightly pushes. Those are decisions that need to be made, and it's important that the organizational structure is clear so people know who to go to for what.
Without that clarity, you have the opposite of transparency. You could say it's open and it's available, but to quote Douglas Adams, if it was filed in a cabinet in a sub-basement behind a sign saying "Beware of the leopard," it's kind of irrelevant. Everybody needs to know who's the incident commander, who's the communications lead for the incident that's going on. What are all the roles? Actually, clarity of roles makes happy human beings and allows us to get through whatever crisis we're in.
Yeah, and just finally, I know we keep bringing this up, but there is something so magical about removing the blame, because it is, again, it's very difficult to do development and operations, I think, at this point in time. The change is happening fast, there's churn that happens within teams, and to just be able to write it down and say, we're going to fix this. Doesn't matter what happened, this is software, there's going to be bugs, and we should be open about that.
I like to think of it as celebrating new mistakes.
Yes.
Don't make old mistakes, those are boring, right? And the process should take care of that. But let's celebrate the new mistake. Wow, that's really cool. What did we learn? Boy, that was pretty foolish, but we're going to automate our way out of that. So it all logically flows with sort of this open approach that spreads the wealth, both internally and externally, and benefits from global participation, right? This positive sum game of open source. So Kubernetes, which we actually use very heavily, right? Usable everywhere. Istio, starting to transform the world of service meshes, the ability to have observability into the services across the organization, regardless of whether it's on a container or a VM or even on bare metal. And most recently, a project called Asilo, which is an open source framework for being able to do confidential computing, right? To take advantage of a world of different trusted execution environments that you can get from AMD or Intel or all of the other chip manufacturers, right? In a world of security, security becomes part of the DevOps mission as well. So when we think about speed of implementation of containers, we also have to think security. What if you don't trust the host with your IP, but you still need the economies of scale? A silo will give you trusted encrypted runtimes as well as transmission of data securely. So if you don't trust the host, go ahead and use a silo.
So I want to throw in,
Go ahead.
so all those build stats that I kept putting up there and talking about build and test automation, we've also open sourced Google's build system. It's called Bazel. And would love your feedback, would love contributions. That's something that I think we can all contribute to, and we've seen contributions continue to increase. And then Spinnaker, which is an open source cloud deployment solution, works multi-cloud, great collaboration across a bunch of different companies. So would love your feedback on that as well and contributions.
Absolutely. We don't hold that our opinions are the only opinions, but without opinions we can't build our software and move at speed. So if there's other things that you think we should be doing, we want to hear it. And we want to continue participating. There's a whole movement around infrastructure as code, policy as code, a lot of amazing projects happening which we're adopting, and we want to share what we're learning with you. So I think that's really kind of the theme. Like, you better be holding hands because this is a hard mountain to climb.
And I think one of the things that just keeps coming up in the work that we're doing, both in open source, with our customers, with our partners, is that we are all contributing to this space. We all have an opportunity to reduce toil as practitioners and to build great applications for users outside of this room to benefit from. So collaboration and partnership is critical for this work that we're doing together.
Awesome.
So, thank you.
Thank you. All right.